everyone, so we are going to do 1.4 shift, reflect, and stretch. We are going to construct graphs and translate them, dilate them, reflect them. So starting with rigid transformation. When we use a rigid transformation, we're going to leave the size and shape of the graph unchanged. So we'll be looking at translations and reflections. A non-rigid transformation is where we change the shape of the graph by doing a horizontal or a vertical stretch or shrink. So the first transformation that we're going to do is a rigid transformation, and it's called a vertical transformation. A vertical transformation is simply going to shift the graph up or down. If we add, it's going to shift the graph up. And if we subtract a value, which we'll call C, we're going to shift the graph down. So looking at this, because this is a +2, it means we're going to take the quadratic function, which is a parabola, and we're simply going to shift it up 2 units. So if we start with our regular parabola, we start at 0, 0, we go right one, up one, and then right one, up 1, 2, 3. And then you could go right one, up 5. It's called the 1, 3, 5. If you have not learned how to graph a parabola, it's a really great way to graph it. So again, you go left one, up 1, left one, up 3. And then if we had room, we would go left one, up 5, the 1, 3, 5 graph. So now if I just dot in, here is a regular parent function. We take the parent function and we translate it up 2 units. So I'm simply going to move this up 1, 2, and then it has the exact same stretch. Right one, up 1, right one, up 1, 2, 3, and we're off the graph. So I can use symmetry to graph the left side, and then I can fill in my graph. And that looks really terrible. Let's see. It's super hard to graph with this pen. So the green is the y equals x squared, adding the rigid transformation of up 2, which is called a vertical shift. The rigid transformation is going to be left or right, which is called a horizontal translation. Now, horizontal translations, I always tell my students it's opposite of what you think, because if you are adding a value inside the function, here I'm adding 4 inside of that function, it's going to take you to the left 4. And if you subtract a value inside the function, it's going to take you to the right 4. So looking at the parent graph, we have y equals the square root of x. Y equals the square root of x is going to look something like this. And if you're not sure, you can always use a table. The square root of 1 is 1, so I went right 1, up 1, and the square root of 4 is 2, so I went right 4, up 2. Now the horizontal translation is left 4, so all I do is I take this parent function and I move it left 1, 2, 3, 4, and then I draw in the exact same graph. So I have a point here, and I have a point here, and then I draw my graph, and that is the horizontal transformation, which happens to be a rigid transformation. Here's my graph, and is reflection. So reflection is a flip of the graph over one of the axes. If there's a negative out in front of the function, we're going to reflect over the x-axis. If there's a negative inside of the function, then we're going to reflect over the y-axis. So this problem didn't have an example, so I just wrote it in. Y equals the opposite of the square root of x. So let's look at what the parent graph would look like. Here is the parent graph, and it looks something like this. And we're going to take this parent graph and we're going to reflect it over the x-axis. And the reason why it's over the x-axis and not the y-axis is because we have this negative out in front. So here's the x-axis, and let's reflect that graph over the x-axis, and it's going to look something like this. And so here's our graph, and it's got a little bit more of a curve. It's hard to draw it with the pen, but here you go, and it looks something like that. So now let's look at the graph where the negative is inside with the function. If the negative is inside with the function, then we're going to reflect over the y-axis. So here is my graph. It looks something like this originally, and now it's going to reflect over y. So reflecting over y is going to make us move to the left instead of to the right, and it's going to look something similar to this. So let me write this in. It's reflecting over the y-axis. So this one reflects over the y with the negative in the inside of the function. I recommend you stop the video and then you just go through and try to shift, reflect, and stretch. So we're going to start with a reflection. This negative is going to make the parabola reflect over the x-axis. So if you're describing it, make sure that you put x-axis. So it's going to reflect over x-axis. The x subtract 1 quantity squared, that subtract 1 is inside the function with the x. And so that's going to make us go opposite of what we think, and it's going to move us to the right 1 unit. So right 1 unit. And then the subtract 3 is going to take the parabola. The parent graph is y equals x squared, and it's going to make us move down 3. Exactly what you think. If it's subtract 3, it's down 3. So let's start at 0, 0. Let's move to the right 1, and let's move down 1, 2, 3. Now this parabola, instead of opening up, is going to open down. And so we're going to just go ahead and open down, and we're going to get something that looks like this down below. Kind of missed that point. All right, thanks. So the next thing we're going to do is look at horizontal stretches and shrinks. If we have y equals f of x over c, and c is a number that's greater than 1. So here's an example with c being 2. We're going to get a horizontal stretch, which means the graph is going to stretch horizontally and get wider by a factor of 2. Now, if we have y equals f of x over c, and we need a horizontal shrink, then c is going to be a number less than 1. So you can see if I put c as 1/2, see how it's in the denominator, and then I simplify this, I get this right here, which is a horizontal shrink, all right, by 1/2. You take the reciprocal of these numbers. So let's look at example number 5. So looking at example 5, the parent graph y1 is an absolute value graph that looks like this. And I plotted 3 points, left 1, up 1, 0, 0, and right 1, up 1. So what we're going to do is if we have y2, inside the function, we're multiplying by a 2. This is actually a horizontal shrink by 1/2, the reciprocal. So you're here, and you're looking at a shrink. If we have y equals x over 3, you take the reciprocal of 1/3, and that's going to be the horizontal stretch by 3. So horizontal stretch is going to make the graph wider, and horizontal shrink is going to make the graph narrower. So what you're going to do is if we took our original 3 values, and we multiplied the x value, which is the horizontal, by 1/2. If you take half, so we're going to take a half and multiply it by each of these x values. So a half times -1 is going to be -1/2. And a half times 0 is 0. And a half times 1 is +1/2. And then we're going to keep our y values exactly the same. So that this new graph, which is the horizontal shrink, is going to be left a half and up 1, 0, 0, and right a half up 1. And so you can see if you look at the horizontal width, so going across is horizontal, you can see that we had a horizontal shrink. Now looking at a horizontal stretch, if we have a horizontal stretch, then we're going to multiply those x values by 3. So we'll take each of the x values in the original parent function and multiply them by 3. When I do that, I get 3 times -1 is -3, 3 times 0 is 0, and 3 times 1 is 3. And then the y values are going to be the same. So I'm going to take and graph these, and because it's a horizontal stretch, my graph should get wider because I'm stretching horizontally. So here, if I go left 1, 2, 3, and up 1, 0, 0, and right 1, 2, 3, up 1. So you can see that this graph is stretching horizontally. And the horizontal, again, is looking at this stretch right there. So it's stretching horizontally. So I think vertical stretches are a little bit easier than horizontal. They're a little bit more straightforward. So if you take a multiplier and multiply it to your function, you are going to get a vertical stretch when that multiplier is greater than 1. What's going to happen is the graph is going to go up quicker, and so it will get narrower. Now, if you take the multiplier and you want a vertical shrink, then that multiplier is going to be between 0 and 1 when you're looking at its absolute value. So this is a typo. Let's use that right there. So you may need to pause and write that in. All right, so looking at this, it's pretty straightforward. Y equals the absolute value of x. This is my same graph that looks like a V. And so when you're looking at a vertical stretch, notice that number 2 is greater than 1. So you have a multiplier that's greater than 1. So basically, if you have your original table, so here's my original table of left 1, up 1, 0, 0, and right 1, up 1. You're going to take that original table and you're going to multiply this time the y value because it's a vertical stretch. And you're going to multiply those y values by the exact number, where horizontal, it's always the reciprocal. And so this is going to give me a new table, and my new table is going to be left 1 up 2, 0, 0, and right 1 up 2. And I'll use red. So left 1 up 2, 0, 0, right 1 up 2. And you can see that this graph got narrower because it's moving up quicker, which is a vertical stretch. If you took a person and you stretched them vertically, they're going to become narrow because you've moved them up. All right. So let's look at the next one. If I take y1 is absolute value of x, so let's put in what the absolute value of x looks like. It's this graph right here. And these patterns work for all of the 12 basic functions. So now if I take my table and I have -1, 1, 0, 0, and 1, 1, and I want to do a vertical stretch, this number is a multiplier out front. And so it's going to be, I said stretch, but I meant vertical shrink. Notice that it's a shrink by a factor of the exact number. So I would take the y values and multiply them by a third. Now I wanted you to notice, if we go back to the horizontal, I took the x values and multiplied them by the reciprocal. So this one, the number was 2, so I multiplied the x values by a half. This one was 1/3, so I multiplied the x values by 3 because it's based on this formula here. So now we're using y values and we're multiplying by the exact number. So I don't know why that reads a half, but it's a third. And let's write down what this new table then would be. The x values will stay the same. The y values are going to move to a third. So looking at this, we're going to go right 1 and up a third, 0, 0, and left 1 up a third. If we end up going right 1, 2, 3, we're going to be up 1. And left 1, 2, 3, we're going to be up 1. And so you can see that this graph vertically is a lot shorter. When we're talking about vertical, we're talking about, here's the original vertical, and then we have here is the new vertical. So you can see that this is a vertical shrink, all right? And if we look at the graph above, here is my original graph. Ooh, that looks terrible. And if we're talking about vertical, so here is my original, oh, this one is my original vertical, all right? And then this one is my new vertical, and you can see it's a vertical stretch in the top one and a vertical shrink in the bottom one, all right? Now, vertical shrinks and horizontal stretches are the exact same thing. They're just opposite of each other, and you get the same graph. If you have a vertical shrink, you get a horizontal stretch. So looking at this graph here, it's a vertical shrink, but it ended up being a horizontal stretch from that original function, which is in the blue. So this problem is example 6, and this is representing f of x. And what we're going to do is take f of x and we're going to reflect it. We're going to stretch it or shrink it. We're going to move it left or right, and then we're going to move it up or down. So how this works is the negative in front is the reflect over the x-axis. The half is a vertical shrink by 1/2. Because it's a multiplier in front, we're going to say vertical shrink, although it's also going to stretch it horizontally. The x subtract 2 is going to shift this to the right 2, opposite of what you think. If it's subtract 2, it's right 2. And the plus 1 is going to move us up 1. So when we look at this, I took 1, 2, 3, 4 points, and I wrote them down right here. I started with the horizontal shift because it's in the parentheses. So it's just like PEMDAS, you're going to start inside the parentheses first. If it's x subtract 2, that's going to move it all 4 of these points to the right 2. So how this works is you would add 2 to all of the x values. So -3 plus 2 is -1, and so forth. That means this point's going to move 1, 2, and now it's going to be left 1 and down 2. This point here is going to move 1, 2, and now it's going to be right 1 and up 6. Add 2 to the 1, and it's going to be 3, 4, which this point is now here at 3, 4. The last point, which is here at 3, 4, is going to move to the right 2, which is now at 1, 2, 5, 4. All right, the next thing we're going to do is we're just going to reflect these new 4 points over the x-axis. So I'm going to erase, we're getting so many points on this graph that I'm going to leave it to the 4 points. So our 4 points are here, 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 and here. So now to reflect over the x-axis, if I were to take this point and reflect it over the x-axis, instead of being down 2, it's now going to be up 2. All right? And so you can see what happened is this, when it reflects, the sign changed to a positive 2. So these ordered pairs are going to be -1 and up 2. This one would be right 1 and down 6. This one would be right 3 and down 4. And this one would be right 5 and down 4. So it reflected over the x-axis by changing the sign of the y values. All right, so see how this here is up 6? Now it's going to be down 6. This point here, instead of up 4, it's now going to be down 4. 1, 2, 3, 4. And this point, instead of being up, is going to be down 4, which is here. And I'm going to go ahead and erase the green values so that we always are just working with those 4 points. All right, so order of operations, the next thing I want to do is I want a vertical shrink by a half. So in order to shrink it vertically, I take the y values and I cut them in half. So now I am looking at -1 and half of 2 is 1. 1 and half of -6 is -3. 3 and half of -4 is -2. And then 5 and half of -4 is -2. So now I'm going to graph these values. I'm taking left 1 and I'm going to shrink it. So notice that shrinks it in half vertically. This point right here is going to be a right 1 and only down 3 because this vertical distance from the x-axis got shrunk down to here. And then this one is right 3 and only down 2, and then right 5 and only down 2. So now I'm looking at these blue as my new values, all right? So I did the shrink, I did the reflect, I did the horizontal translation, and the last translation is moving everything up 1. Well, when you think about it, if I move this point up 1, it's now going to be -1, 2. So basically, I'm adding 1 to all of those y values to move it up. All right, so let's do that right now. This is going to be -1, 2. This one would be 1, and if I add 1 to -3, I get -2. If I add 1 to -2, I get -1. And if I add 1 to -2, I get -1. So this is going to be my final function when I did all of the shift, reflect, and stretching. So this is going to be right 1 and down 2. This one's going to be right 3 and down 1, and then right 5 and down 1. I'm going to go ahead and erase those blue points, and the purple is the winner. This is my final graph. So it's connect the dots, and it's really hard to connect the dots on this screen, but you're going to connect the dots, and there's your brand new function. And you did all of the shift, reflecting, and stretching that goes with it. And try the U-Try problem on your own, and then don't forget to do the reflection. Make sure that you're using your Cornell column to take notes, and make sure that these notes have the date on them that you did them. So Thanks and have a great day. Where do I turn this off?